little bit different, and I'd like to just kind of tell you about what makes them different. So the two types of main standards that we have, the first one is prescriptive, and that explicitly states what to do and how to do that. So a good example of this would be, I need to build a 1-hour fire-rated wall. And what companies like Underwriters Laboratories and even Intertech actually done is they built a whole bunch of different fire-rated walls. And they said, okay, well, if you build it this way, it will become a fire-rated wall. And it's just like, okay, you need to use, you know, a 2x4, either wood stud or metal stud. You need to fill the cavity with an insulation. And then you need to put 2 layers of 5/8 inch thick gypsum board with basically jointing all of the seams in between each layer. And that construction becomes your compliance. You have followed the requirements, the exact construction. You follow that. It told you what to do and how to do it. This is how you build it. Performance standards, on the other hand, they use a set of criteria that says, okay, well, if you meet these testing qualifications, you can build it any way that you really want. To some degree. We'll get into that later. So a good rule of thumb here is actually, and I wrote this down, is from the ESTA standards. And so there's, for fire safety curtains, this is a good example. It's ESTA E 1.22, and then it's clause 1.2.4 says a fire safety curtain shall reduce transmission of radiant heat, block debris, and continue to control smoke and the movement of gas for a period of 20 minutes. So it gives you the parameters of what your fire curtain needs to do, but doesn't tell you necessarily what your fire curtain, you know, how it's constructed. So there are other parts of different standards that will tell you a little bit more detail on, oh, you need to use this and not this. Oh, maybe we shouldn't be using asbestos anymore for those fire curtains. We need to be using some other types of material. So it's not carte blanche, but it's giving you a condition for this is how you verify whether or not you're in compliance. Most standards, however, are kind of a combination of prescriptive and performance, where if you look at ESTA E1.1, which is the construction and use of rope ladders, it has a combination of both. For on the prescriptive side, it'll say the rung outside diameter shall not be less than 1 nor larger than 2 inches in diameter. But then it also has some performance based where it says the rung material must be such that a 3-inch wide load of 1,000 pounds applied to the center of the rung cannot cause permanent deformation of the rung. So it's got both. It's telling you the size it needs to be, but then it's also saying you can use any material as long as it meets this test parameter. Okay, codes. Most codes are model codes. And what does that mean? People get together, and in the case of the National Electrical Code, they're called it. It's a code panel that gets together, and those code panels get together and they look at the standard, they look at new technologies, and they write requirements for their installation in the National Electrical Code. And then we vote on it. And once that happens and they're in print, we pretty much what happens is they say, hey, here you go. If you want to use this in your jurisdiction, it's written such that you can go ahead and use it. So political jurisdictions actually vote on whether or not they're going to adopt the requirements of the National Electrical Code. And they can adopt it in whole, they can adopt it in parts, or they can add or subtract material to meet their local jurisdiction requirements. And then once they've done what they want to do with that model code, then they make it and enact it into law. It's kind of very similar to how a bill becomes a law. If you ever remember that Schoolhouse Rock, it's very similar in that particular way that they actually do this. And then what happens is your local authorities having jurisdiction, your local inspectors, those are the guys that have the responsibility of interpreting the code and giving final approval. So that's how codes work in most cases. And this applies to the National Electrical Code, the building codes, and the plumbing codes. That applies to all of those types of codes. Regulations are kind of enacted a little bit differently. It's kind of a little bit backwards. First, a law is passed, and then executive agencies, they go ahead and they say, okay, well, we're going to write a legal norm based upon the law that was passed so we can shape conduct. And a good example of this are OSHA regulations that we have out there. Laws were passed to protect people, and then the actual legislation or the regulation was actually written by OSHA or somebody else. California Proposition 65 is also another really good example of that. And that is a regulation associated with safe drinking water and a Toxic Enforcement Act that happened here in California in 1986. It was actually put into place, and the reason for that is people were dumping all kinds of contaminants into the water stream. So people basically said, you can't do that anymore. But in addition, they developed a list of all these chemicals that you watch out for that either have cancer or reproductive harm issues. And then you take a look at that list and you see, does my product have anything in it that's on this list? And you may put a label on your product that says, hey, there might be something in this product that, you know, causes cancer or reproductive harm. It's kind of an interesting thing. The reason why I brought that up is if you ever purchase a piece of ETC equipment, then you're in the United States. You will absolutely see a California Proposition 65 label on the product. And the reason for it is, from ETC's standpoint, is because there is nickel in our product. And that, according to the California Proposition 65, is potentially a cancer-causing agent. So we actually have to label our product, but it's nickel. Just by the way, you can take a look at all the list of everything that's on Proposition 65, and there's over 960 chemicals on that list. So including Wood dust is on the list, and also Chinese salted fish. So it's kind of a very large, all-encompassing document that they have there. But it's a regulation. Industry practices, these may or may not be written down. That's something that you need to know. An industry practice is something that's accepted and recognized method that people use in a specific industry, and is not specifically documented. Best practices are often used and based on codes and standards and information from knowledge experts and qualified persons. When they are written down, they become guidelines or recommendations. Those are kind of the terminologies that you actually see for industry and best practices. So ESTA. If you do nothing more, go check out ESTA's TSP website. And because ESTA is the only ANSI accredited standards program for the entertainment industry. These are standards written for us. And I have a couple of website links here at the bottom. First is just to the TSP. And that stands for Technical Standards Program, by the way. And that is where you can go and you can download these standards. You can take a look at them. At very least, at least go there and look at the titles for these standards that exist, so you know what's out there. So if you get in a situation, you're like, oh, hey, yeah, I remember seeing something that covered this in an ANSI, an ESTA standard. So I'm going to go back and I might go ahead and read this. And you can see there's a lot of different groups that are covered under ESTA's technical standards program. I actually is set in with the electrical power group. Something to note is that ESTA standards are recommended practices. But they're often seen in informational notes of the National Electrical Code or UL standards, even possibly some building codes, some IEEE stuff. So they're incorporated, although the recommended practices here, they are enforceable. Once again, going back to the idea of if you don't follow things that are recommended practices for a particular industry, people can deny you benefits or people can get hurt. That's the biggest thing that you should realize, that these things are always out here to get everything together. S is kind of interesting. The DMX 512 standard is something that exists out there. And DMX 512 started as a bunch of people got together in the mid-80s. It was about 1985 at USITT. A lot of stuff happens at USITT, by the way. And it was basically a lot of people who had rental houses, and what happened was at that point in time, all the manufacturers were basically coming up with their own control protocol. And if you can think of somebody who owns a rental house and what that would mean to them, it's kind of interesting because now they have to have this person's equipment for this person's protocol and equipment for that person's and equipment for this. And now they've got a whole bunch of equipment that has to be bought So they can have rental stock so somebody else can use it based on what house or what place they're going into that deals with that specific protocol. So what happened is these people came together and they said, hey, we have to get control over this because this is going crazy. So they actually came up with BMX 512 and wrote a standard for it. Now, at that time, that standard was held by or worked on by the engineering commission at USITT, and it got published and it was out there, but it wasn't actually an accredited standard. And a lot of ESTA standards started that way. They started with a standard that was written, and USITT, it was under USITT, but in the 90s, basically, it was 1998, I believe, ESTA started this TSP, and all those unaccredited standards came over to ESTA, and they became ANSI accredited standards. So there's there's history behind all of these standards that exist. That very bottom link that I have here is for protocol or articles. That's a really neat place to go in and read and see what is going on in these different standards, what's coming out next. So you're actually informed. And later on, I'm going to talk about one that actually impacts a lot of people, pretty much everyone out there. So, National Electrical Code, switching gears. I just wanted to show you the organization of the National Electrical Code. The first 4 chapters, and this is current, the first 4 chapters are just general, electrical installations, and, everything in the first 4 chapters basically applies throughout the National Electrical Code. However, chapters 5, 6, and 7, which are special occupancies, special equipment, and special conditions, they can modify what exists in chapters 1 through 7. So, although chapters 1 through 4 are general use, you can have areas in these additional chapters that say, okay, sorry, excuse me, I have the hiccups. This applies, however, this rule in chapter 3 doesn't apply. So it modifies different statements. These chapters are kind of important because when we're talking about theatrical occupancies, those are in chapter 5. So although the National Electrical Code as a whole applies, there's special conditions that you may come across, or special occupancies that modify those requirements in chapters 1 through 4. So we're going to take a look at that, but first we're going to look at some general definitions that you find in the National Electrical Code. I didn't have them all, but these are ones that I think are really important. And the first one is listed equipment. You'll find that they'll say that, oh, hey, a luminaire used for stage and studio purposes needs to be listed. And what that means is that equipment was evaluated by a nationally recognized testing laboratory like UL or ETL or TUV. Those are nationally recognized testing laboratories. And it was tested in accordance with the applicable standard And those applicable standards may actually have a specific purpose. That is important in our industry. There's a big difference between the requirements for a stage and studio luminaire meant to be used in the theatrical industry versus just a regular luminaire that you would have in your home or in a hotel or a business. And because of that, if somebody went out and purchased, if you go out and purchase, let's say, a Source 4 Series 3, and you're going to install it in your hotel lobby, you need to be very well aware that the authority having jurisdiction might look at that and say, hey, this device says I'm a stage and studio luminaire, and it is not actually placed in a stage and studio occupancy. Therefore, it's not actually suitable for that area by the rules of the National Electrical Code. And then you have to say, oh, okay, I have to get a regular general luminaire that was evaluated to a different standard. So you have to be aware of that. And a lot of companies now, because of the use of LED technology, a lot of the specific requirements that used to be hazardous to be used in a general area, if you're a stage and studio luminaire, those have kind of actually gone away. And a lot of companies are now listing some equipment, if they think it might be used in a general area, to the basic just luminaire standard, so it can be used in lobbies and in hotels and so on and so forth. But so that's something to look out for if you were somebody specifying equipment for a location. You want to look at what is it listed for. Okay. Shall is it must. You have to meet the requirement. There's no ifs, ands, or buts here. Should is a heck of a recommendation that you should be doing this way. It's not required, but you better darn well have a good reason why you're not following should, because it comes back down to, hey, this was a recommendation. Why didn't you do this? In a court of law, they will ask you those questions. Qualified persons. Our industry relies a lot on qualified persons. It's one who has demonstrated the skills and knowledge related to the construction and understands the hazards, and is able to reduce any kind of associated risk. So there's a program, and it's actually run through ESTA, which is you can become a qualified electrician, you can become a qualified rigger, you can do these sorts of things. And it's something that if you're going into a particular industry where you're working more on sites, even in an engineering capacity, you may want to consider that as an option for yourself. So having these qualifications. Now, you don't necessarily have to have certifications to become a qualified person, but it's something that is kind of shows that you've demonstrated the skills and knowledge. Okay, we talked a little bit about nationally recognized testing laboratories. I've also heard people call these NERDLs, kind of like turtle, but it's a NERDL. And the most common ones that you will see in the United States and Canada are UL Solutions, formerly Underwriters Labs, and you'll see the little, I put the logos there that you typically see that are on the products. ETL or Intertech. And on these, the C stands for it was evaluated for Canada, and the US stands for the fact that it was evaluated for use in the United States. So a lot of these will have dual markings on them. There's also the Canadian Standards Association that exists out there, also known as CSA International, and they have their logo. TUV is usually a European base. That's where they started, but there's also TUV Sud, which is based here in the United States, and TUV Rhineland, which is based over in Germany. They're actually different companies under the same umbrella, and they're able to be in NRTL for products that are listed in the United States. Right now, there's 21 companies that actually are NRTLs, and they are governed by OSHA. And you can actually go to OSHA's website and get a list of who is an NRTL. And that's important because if you look at a product, you want to know that it's actually listed. So if you go out there and you look, it's like, oh, okay, well, here are the logos of these companies. And oh, yeah, this is a company that actually is a nationally recognized testing laboratory. And this is a piece of equipment that's listed. So when the National Electrical Code says the product needs to be listed, you know you've got something there that's actually listed. Things that don't count in this direction are CE. CE is a self-certification mark for Europe, and it does not show it's not part of the NRTL program, and it's not a listed product. So if you only got a product that's CE and you want to use it in a place where the NEC says it needs to be listed, that is not going to count. Also UKCA, which is Europe's version, which is the UK's version of CE in Europe. EAC, which is for Russia. There's a whole bunch of other ones, but the main thing is to really know that I can go to OSHA and I can see who is a nationally recognized testing lab, and I can make sure that whatever mark on the product, I have one of those marks. So more on the National Electrical Code, which is also called NFPA 70. These are entertainment-specific articles that exist. The first one is assembly occupancies. And assembly occupancies can either be a building by itself, or it can be part of a building where 100 or more people are meant to occupy that area for any kind of theatrical show. If you're less than 100, it doesn't actually fall under Article 518 as assembly occupancies. However, it could still be a theater or an audience area of a motion picture, television studio, those sorts of things, similar locations like that. Article 520 has got, it's kind of where a lot of the business end is for our industry. And it deals with both fixed, permanently installed equipment and also portable equipment. And it talks about those requirements for both. And one thing to mention here is that portable equipment is not temporary equipment. And that is something that people still struggle with in our particular industry. I knew a gentleman who ran a house. He was the house guy, and every 90 days he would take down his plot, and then the next day he would put it back in, because he thought because he was using extension cables to go out to the luminaires on the electric, that it made it a temporary installation. So in those rules, he's like, well, I have to every 90 days do this. It is not. It's not a temporary installation. It's a portable installation has completely and utterly different requirements to it. So realize that, where we fall in that particular area. Article 522 is control systems for permanent amusement attractions. 525 is carnivals, circuses, fairs, and similar events. So a lot of events that might actually be they're installed and they rotate around. 530 is motion picture and television studios and remote locations. That has gone through some major revamps in that particular area. In the last code cycle, everything moved around in that area. So that's kind of, if you've ever looked at it, it might be a good thing to review it again. And Article 540 is motion picture and projection rooms. Other useful articles. Article 700, which is emergency systems, including emergency lighting. We keep on gaining and learning things in emergency lighting. And there's been a lot of changes here in the last couple of code cycles. And what's really going on is people who are designing lighting systems for buildings, they're sitting there going, I don't want my emergency lighting to be these ugly exit things with these big honking floodlights on the front of them. They want to incorporate emergency lighting that looks good, lo and behold, and does still have that emergency functionality. So there's been a lot of changes here. Also with the advent of LED technology, we have a lot of people building luminaires that are connected to class 2 power sources or power over Ethernet, really common now. And in the last code cycle, what happened was they were noticing that these power over Ethernet wires and these class 2 wires that people might be using, those weren't run correctly because no one addressed that topic in the National Electrical Code. They were just running them randomly with everything else that was power over Ethernet or class 2 wire, and it wasn't segregated. Emergency lighting has to be separate from all other wiring. So what they ended in, it's just so you know exactly what it is, and it has to be marked. It has to be labeled, hey, I am part of the emergency circuit. So people know where to go if there's a potential issue. And that wasn't being done with this power over Ethernet and class 2 wiring. So in the last code cycle, they put it in it. And they basically applied what the requirements are just for what you would consider standard emergency lighting systems that were on, let's say, 120 or 277 volts. And they applied those requirements to that. Article 725 is class 2 and class 3 power limited circuits. This is still, and for some reason will always be a continuing issue in our industry. I want to raise this flag here and say DMX is a class 2 circuit. Okay, it is required to be wired using class 1 wiring methods. Or sorry, class 2 wiring methods. My apologies. You are required to use class 2 wiring methods. You cannot take a DMX circuit and run it in the same conduit as your power circuits or any other class 1 control circuits. That is not allowed. And we have more than enough evidence to see what happens when people have done this. There's a thing called capacitive coupling. And what happens is the voltage from power circuits or from class 1 wiring can actually get onto the class 2 circuits and now create a shock hazard to the person who has got that DMX 512 connector in their hand. You can actually get a shock. And if you're standing on top of a ladder and you've got that voltage there, then the chances of you getting shocked go up. And if you get shocked on a ladder, what's really going to happen is the shock's not going to kill you or hurt you. It's going to startle you, and you could potentially fall off that ladder, and that's where you're going to have a problem. But what confuses people here is 0 to 10 volts and dolly circuits. Those are class 1 wiring methods, and those can be run with power circuits. Okay, so that kind of makes people think, but the DMX should be able to be run that way, and that is not true. Dolly and 0 to 10, they're class 1. You can run them together, but leave your DMX separate, please. Other important standards for us to be aware of, and I'm not going to go into any kind of details here, is NFPA 70E, which is your electrical safety in the workplace. This is what an employer should be taking that information and establishing a document, documenting and implementing an electrical safety policy. That is what NFPA 70E is really meant for, is like, hey, employers, if you have people working with electricity, you need to tell them how they handle that electricity. So there should be something in place with your employer that provides those policies to you. That's what NFPA 70E is for. NFPA 79 is for industrial machinery. And where that comes into play is your hoist systems, that you have. Hoists are considered industrial machinery. So if you're doing anything with motors and with hoist systems, you should probably give a look at NFPA 79. And then NFPA 101, which is the life safety code. And this is meant to provide an environment for occupants that is reasonably safe from fire. So where this comes into play is providing information on materials and how they should be used, providing information on how you should go and you should check your emergency lighting systems, and that they need to be, any of your emergency systems that you have in there need to be checked every 30 days. That is a requirement out of NFPA 101. And it basically, these are things that your employer should be making sure they are doing to give you a safe working environment. Okay, let's take a look at some future items here. What's very near? ESTA E 1.80. And this is all about pinout configuration markings on special purpose multi-circuit cable. And this comes into play within the National Electrical Code. In the 2026 version of the National Electrical Code, it is, and this is section 520.68D, It will not only require you to mark what is the voltage on the conductors in the cable, but also your pinout configuration. So you want to take a look at that. Currently, the National Electrical Code tells you you have to put the voltage on that cable. So you have to say whether or not it's 120 volt circuit or a 277 or 240 or whatever you're using it for. You actually have to tell people what is it being used for. But the pinout configurations will be really interesting for everybody to get used to, but the people who worked on E1.80 took a whole survey of what is actually out there and have come up with a code that tells you what the pinout configuration is. So you don't have to mark everything with this is hot, this is the neutral, this is circuit one, this is, you don't have to do that. What you're going to say is this is an A1 configuration or an A2 configuration. So people have given just names for those configurations. So you would say, as an example, A1, 120 volts. I don't know if that actually corresponds because I'm not looking at the standard right now, but that was just as an example. So these will be things that you need to end up doing. Energy efficiency standards. Now, these have been out there for a long time. Yeah, ASHRAE 90.1 is 50 years old. So why is this stuff in this section? Well,
Wendy, sorry, I hate to interrupt, but we're coming really close to 1 o'clock. I just want to be sure that you're aware of the time.
I'm at the last couple of slides
Okay,
anyway.
great. Yep.
And what I'm actually going to do here is I'm going to just say that efficiency standards are actually driving what we're doing right now. And us being able to get incandescent lamps for our old Source 4 products, that's going to start going away eventually. And we're going to have to go over to all LED equipment. I'm going to skip over there. The other topic is cybersecurity. Although it doesn't really impact our industry yet, it is going to start impacting our industry. And that's what I have. Questions?
Wendy, thank you for all of that. And sorry to rush you through those last two. I did want to be sure we had some opportunity for questions. Anybody in the room right now, if you've got a question you want to ask, go ahead and throw it up into the Q&A panel. And while we wait for that, I'll ask one that sort of is burning for me. It's a two-part question. And we were talking a little bit about this, Wendy, before the group joined us. I connect with a lot of folks who say, well, those don't apply to us because it's theater. It's sort of more broadly sort of said, well, theater folks don't have to worry about these things. What is the best way to respond to those folks? That's sort of part one. And part two is what, say like in a social media group or an email chain, what liability do I carry if I start responding to those questions? Right. And maybe you're not the right person to ask that question of, but it's this thing that I worry about, right? Like, do I have to tell people the right way to do stuff? Am I somehow responsible if I don't speak up, if I'm part of that group? And then what kind of trouble can I get in if I do speak up?
Oh, yeah, those are big questions, actually.
Yeah.
To address the first one, the one thing that I would say is that these standards are there for your safety as well as everybody else's. And you could be in a situation, and if you've ever talked to Justin Bennett, just to throw a name out there, you could be in a situation where you could be looking at something and saying, I'm not sure this is safe anymore. And how do I protect myself? Well, knowing the standards is what helps you protect yourself in a situation where maybe your employer is not necessarily taking care of you, because in all honesty, sometimes it costs a fair bit of money to make sure you comply with these standards. But the
Mhm.
standards are there for you to say, you need to comply to this.
Yeah. Yeah.
This is your legal obligation to me as an employee. And if they don't, there are ways to move forward and just say, no, we got to take care of that.
Sure.
So that is kind of the main thing I would say, is that they're there for your protection.
Yeah. Yeah.
The second thing on being part of a social media group and offering information is a very difficult one. And I know that from the engineering commission side, because a lot of commissions, USITT commissions, actually have social media accounts. We specifically didn't do that.
Hmm.
And the reason being is a true understanding of the code kind of takes a long time to do.
Sure.
And it's not that you can't reach out to us, but the people who should be reaching out to are actually the people who are in the codes and standards, those names. And they're written in the front, and a lot of the times, like the ESTA standards actually provide phone numbers and email addresses.
Right. Yeah.
So those are the people that you should be getting a hold of to say, hey, am I doing this right? Is there something there? And we talk to each other and make sure that we're coming up with, a correct answer for the individual, and make sure it's vetted.
Sure. It takes more than 280 characters to talk about this, basically, right?
Yes, it does.
Yeah.
Yes,
Yeah.
it does.
So what I'm hearing you say is be cautious in those situations and maybe move those conversations out of uh, the social media venue where it feels like you have to answer quickly, and
Mhm.
make sure that there's time to have a robust conversation. Am I summarizing that well?
Yeah, that's a great summary.
Okay. Um, Folks, we're at 1 o'clock. I didn't see any questions come up in the question and answer. So I guess we'll go ahead and wrap up here and say, Wendy, this was fantastic. There's a lot of information here. The old English major in me was really excited to hear you talk about the importance of language and words and standards versus best practices, and what does qualified person mean, and all of that. We Again, in my experience, those of us in the theater side of the entertainment industry tend to shy away from that. It feels too corporate to be that specific, but it's so important. And so I'm grateful for you sharing all of this. Um, Stay tuned for our next First Friday in October. And already I'm forgetting what the content of that is. My apologies, but you can find it on our website, centers.purdue.edu/fusion-studio. Thanks everybody for being here. Thanks again, Wendy. It's great to hear all this information, and we'll see you next month.
And if anybody wants to get a hold of me, they can contact me at wendy.russell@etcconnect.com. So if you're too shy to ask a question in the room today, which does happen, please feel free to drop me a line.
Awesome. Thanks, Wendy. Are you okay if we share that email address on the
Sure.
information about this webinar? Awesome.
Yep.
We'll do that. Thanks, everybody. And again, we'll see you next month. See y'all.